Another type of story problem I want to go over from 1.2 is called a motion problem. Okay, and what's important here is that we know distance equals rate times time, or simply d equals r times t. Okay, so, and of course you can rearrange this, right? You could of course make this rate equals distance divided by time. Just think about it. If you're traveling 60 miles, the distance per hour divided by the time. So you can use it in a number of ways, but I'll just use regular distance equals rate times time. So here's the problem. Joe traveled against the wind in a small plane for 3 hours. So he's flying and there's wind coming at him. The return trip with wind took 2.8 hours. So instead of flying against the wind, he's with the wind. That makes sense. He's going to get there quicker then. Find the speed of the wind to the nearest tenth if the plane speed in still air is 180 miles per hour. So if there's no wind. Okay. Now, with this type of problem, it often helps to make a table. Notice I have distance, rate, and time. And I'm going to fill in what I know. I have one row for against the wind, and I have another row for with the wind. Okay? So here's the thing. In both these cases, these distances are the same, right? So distance, I guess we'll say against, is actually equal to distance with the wind. If you think about it, these two have to be equal. That's an important thing to notice. That's going to help us in this problem. Okay. Now, what about the rate? Okay. Well, how fast is the plane going? And you take into account the wind when it's going against. Well, in still air, it goes 180 miles per hour. But if it's going against the wind, it's minus the wind speed, right? Since it's fighting against the wind. That's why I'm subtracting off W. We don't know the wind speed. Okay, that's what we want to find. If it's going with the wind, it's similar, except for it's 180, but it's actually speeding it up. If any of you have ever ran track, you'll know what I'm talking about. If it's a windy day, you like to be running with the wind rather than against. Okay, so how about the time? Well, we're given the time. Against the wind, it takes 3 hours. With the wind, it takes 2.8 hours. Okay, so here's where we're at right now. I got my table filled out. And now the question is, okay, how do I solve for W from all of this? Well, the key is right here, okay? And this won't always be the key. It's not like the distances will always be the same. So that's usually the tricky part, is to figure out how to have a relation. So I know that the distance against the wind is equal to the distance with the wind, okay? So if distance equals rate times time, I can use this rate and time right here. Okay, I'm just pulling right off my table. Okay, and so this is going to be 3 times 180 minus W. That's from against the wind. Has to be equal to this distance with the wind. That's 2.8 times 180 plus W. Okay, so here's what we got. And now notice, this is a piece of cake now. All we got to do is solve for W. Now, remember with decimal equations from the last section, we want to get rid of that decimal. How do we do that? Well, I'm going to go ahead and multiply this side by 10. That way I'll be able to move the decimal over. Can't just do it to this side. Got to do it to both sides. Okay. So what we're ending up with here is 30 times 180 minus W. That's equal to 28 times 180 plus W. You probably already know this, but remember, you only multiply this into one of these, right? Might have been easier if I would have multiplied first. Doesn't really matter. You'll end up with the same thing. Okay. So if we go through and we do our distribution, this is where it's nice to have a calculator. We get 5,400 minus 30W is equal to 5,040 plus 28W. Okay, so that's fine. Now we want to get our W's on the same side, so I'm going to add 30W to both sides. Add 30W, add 30W. Okay, where are we at then? Okay, well now we have 5,040 plus 58W is equal to 5,400. And it's quite simple from now. Subtract 5,040 from both sides, and we'll get 360 is equal to 58W. And then, of course, divide both sides by 58. And you should get W equals 6.2 miles per hour. So the wind is 6.2 miles per hour in this situation.